Hello everyone, welcome to our YouTube channel. So today we will discuss about another machine learning model called price prediction. So we have first such that we will give our model, our collab, our input data, then we will process it. After processing, we have certain demands like we have seller types, we have fuel types, we have it might be automatic or it might be you know manual. So our data is in textual form. We will encode our data into 0 1 so that our machine learning model could understand because we know our machine learning model needs numerical vectorized data. So we will encode this and then we will with the help of test split function, we will separate our data into training and testing data. Then we will feed it to our model, linear and also regression model. Then after giving this data to our model, we will evaluate our data. And then we have graphical representation and see we have certain data points which are more at certain point. So this is predicting how our data, our price will be predicted on the behalf of the actual pricing versus predicted prices. So let's go to our collab and discuss our model, how we code it. So first import our libraries, import pandas as PD. This pandas will help us to read our data set, okay? Then we will import our matplotlib library, which will help us in graphical representation, okay? Then we will import our train test split function from sklearn dot model selection. We will import train test split. Then we will use model linear regression. And from sklearn matrix, we will import R2 score, okay? We have another model which is called as lasso regression. So we will import this sklearn dot linear model import lasso, okay? So we will run our libraries. This mean scale error will help us to predict our scale error in our data, okay? But basically we will import our matrix so we could have all the accuracy score, R2 scale, mean scale error. We will not specifically import only R2 scale error. So we will import matrix, okay? Now we will make a variable data is equals to pd.read underscore CSV. It will help us to read our data set. We will give it our path. Content has been read. Now we will check our info. Basically, it will describe the data types of our data, means in how many integers, object, float types. So this is the data types. So now we will check our shape, how many columns and how many rows are there in our data set. So data.shape, it will print our rows and columns. So we have 301 rows and 9 columns. Now we will we will describe our data. So this will help us to check our count, mean, mode, median, and other like 25%. These are basically statistical approach to see our data set in tabular form, okay? Probability and statistics are doing that. Now we will check our first 5 rows. So we will print dot hat. This will give us first 5 rows according to their corresponding feature names, column names, and attributes. These are basically same column names. So these are our first 5 rows. Now see our selling price, column name, then our fuel type. Fuel type, it might be petrol, diesel, CNG. So basically fuel types are the seller type is dealer, individual. Okay, now transmission is manual, automatic. So these are basically our basic fuel. This is our types, fuel types, seller types, and transmission. This is on which our data, our selling price will be based. So these seller types, dealer, automatic, so on. Now we will check how is there any null value in our data. So we will check data.isNull.sum. It will help us to identify all the null values in our data according to the rows and sum them. So there are no as such zero. There are no null values in our data. Now we will print our petrol, diesel, and dealer type. So basically, we will count our values. Okay, means how many. So first we will check. Yes. Now we will print our value count. So fuel type, how many cars in fuel type, how many cars are on diesel, how many cars are on petrol, seller type, how many are individual seller transmission and so on. We will. There are 239 cars on petrol, 60 on diesel, seller types. There in 195 dealer, individual 190, 106 and so on. We will check our data accordingly. So after checking our data, now we will encode our data because basically our fuel type is petrol, diesel. So for our machine, we have to convert them into vector numerical form. So we will replace it, data to replace with fuel type. We will pass it as a string. Okay, fuel type, no string. Now we will convert our petrol into numerical form. Like we will label our petrol 0, diesel 1, CNG 2, so that our machine could understand this textual data. Okay, so we will encode petrol, label petrol as 0. Then we will label our diesel as 1. And so on, we will label our CNG as 2. Okay. So now, similarly, we will encode our seller type and transmission type. So basically, here are the two seller type, dealer and individuals. We will encode them as 0 and 1. So just pass these values. Now dealer, pass is to 0. Now individual, pass it 1. As now there is no third value of text, so simply remove this. Now again, do it for transmission. Now for automatic, simply remove third one as there is no one in transmission. So now after encoding our data, let's check transmission 0. Let's check now our data is encoded or not. So simply run it. So basically we have missed one thing. We will give it in place 2. It will help us to encode our data. Basically in place default is false, but when we make it true, it means do whatever we have suggested in our function. Okay, as we replace, so it will help us to make our condition true. So simply we will now check our rows. So data.head. So now see the fuel type seller type has been labeled into 0 and 1s. Now we will split our data. Basically we will split our data into target variable, as our target variable is selling price. Selling price is our target variable, and they are based on car name. Basically every car has their every car has their name, and it should have its own selling price. So we will simply convert our value target data. Okay, so we will drop our target selling price data from our restaurant data and pass it to our y variable, like simply x to our remaining and our target data to our y variable, and it should be dropped from our x variable. Okay, so it meets the car and its corresponding selling price. Okay, so selling price. Now pass these drop for axis is 1. Basically axis 1 means column, axis 0 means rows. So now drop this from dash data and pass it to y variable. Okay, now we will we will print our y x variable so that we could see it is dropped or not. Now see our selling price column has been missing in our data. Okay, now check our y variable in which our selling price has been stored. Okay, so print y. Now see our selling price data is there. selling price, name selling price, and 301, float 64. Now we will test train split, means we split our x and y variables into our train and test data. So we will feed our data to our model on the basis of the training and test data. So simply we have import our train test split function, use it there. So train test split. Okay. So simply x train, y train, x test, y test. Okay. So x train, x test, y train, y test. So now give it our function train test split, pass it our variables x and y, then x and y. Our test size should be 20% or 0.2%, and 80% is training, okay, or 0.8% is training. So 0.2. So make it to take any random state. It depends on you. So I will take here 2 random state. Okay. Now run our data, run our cell. So it has been run. Okay. Now check print our shapes, x train shape, x shape, x test shape, how our data is looking like. Okay. So x train shape, y train shape. So now see our 301 rows, 7 columns, because one has row. And now y has 1 column which is selling price. So default is that there is no number is there. Okay. Now we have 9. So we have dropped our 2 columns. Which is basically car name and selling price. So there is 7 columns remaining in our x data and 2 has been in y. So basically 1 is in y, which is selling price. So it is default 0 here. So we will now train our model selection. So basically we will use our linear regression model. So we basically use our linear regression model. Okay. And last model. For now, we will use only linear regression model. Linear, we will make it a variable as linear. Now we will pass it our linear regression function. So now we will fit our x and y train data into our linear model. So x train to y train. So just run it. So our model has been trained. Now we will predict our x train data. Okay. So we will simply make a training data prediction, make it variable our training data prediction. So our linear model will predict our training data. We will training, we will give it our x train. Then we will check now. We will check our error scale because we have import our matrix above our matrix.autoscore, which will give at mean scale error. Okay, like here we have import matrix. Okay, now use this matrix to get R2 scale error. Okay, R2 score, it will give our R mean scale error. Okay, error means basically the difference in our prediction. Okay, so y train prediction, data prediction, in which we have given our x train data. So print our error. Simply we will give it string ask it error. So give it our error variable. So run it. So as there is 0.8% of their R mean scale error. Okay. So it's good for our data because we have very least amount of data, only 301 rows. So this sort of small chunk of data, this prediction is good. Okay. Now we will check. We will plot a matplotlib library graph to check in which region our price is more likely to be predicted. Okay, now, so we will use PLT as scatter. We'll pass it our X train, Y train. So Y train, X train is stored in training data prediction as you see it on. So we will copy paste it and pass it to our PLT.scatter function. Okay. Now we will label our delta actual price on horizontal surface on x-axis, and on y-axis perpendicularly we will give our predicting price section. Okay, so it is actually actual price versus predicted prices. Okay, so plt.x label actual price, y label predicted price. Now with the help of plt.show function we will show our graph. So our graph has been displayed. So now see, this area has most data points. It means it is the area where our predicted price is most actually to be. So this is our outliers, which are some, vast variety. Some cars may have different varieties and some car may be most expensive. So this is how our data will look. So we will take mode of our data so that our predicted price and actual price looks good. If you take more, means you are taking the centermost number of the data, and it is very close to our predicted prices. But if you take mean, like we have 1, 2, 3 number, then we have number at 100. It should be very difficult to predict our actual predicted prices and predicted prices. So that's all from my end. Thanks for watching our video. Thank you.